The most powerful weather phenomena in the universe take place in space, where extreme forces and exotic conditions create events far more intense than anything on Earth. Here are some examples. Solar flares and coronal mass ejections, CMEs. Power. Solar flares are sudden, intense bursts of radiation from the sun's surface, often associated with CMEs, which release vast amounts of plasma and magnetic fields into space. Effect. These events can generate powerful solar winds that affect planets by stripping atmospheres, causing magnetic storms, and impacting space weather on Earth, damaging satellites, power grids, and communication systems. Energy output. A large solar flare can release energy equivalent to billions of atomic bombs in seconds. Quasar winds. Power. Quasars are supermassive black holes at the centers of galaxies, surrounded by an accretion disk of matter being drawn in at near light speed. These objects emit winds up to 100 million miles per hour, 160 million kilometers per hour. Effect. Quasar winds can influence galaxy formation by heating and expelling gas from galaxies, halting star formation and shaping their evolution. Energy output. Some quasars shine with the power of thousands of galaxies combined. Neutron star winds. Power. After a supernova, a neutron star, a collapsed star, emits extremely powerful winds made of high-energy particles and radiation. The rapid rotation and intense magnetic fields of neutron stars drive these winds. Effect. These winds can interact with nearby matter, creating pulsar wind nebulae like the Crab Nebula, and can affect entire star systems. Energy output. A neutron star's magnetic wind can produce bursts of gamma rays and X-rays more powerful than any explosion on Earth. Gamma ray burst GRBs. Power. GRBs are the most energetic events observed in the universe, often occurring when massive stars collapse into black holes or when neutron stars collide. Effect. A single GRB can outshine entire galaxies for a brief period, releasing more energy in seconds than the sun will emit in its entire 10 billion year lifetime. Energy output. The energy from a GRB is equivalent to the energy the sun produces over 10 billion years. Hypernovae. Power. A hypernova is a type of supernova, the violent death of a massive star, but on an even larger scale. It happens when a star more than 30 times the mass of the sun explodes. Effect. The explosion sends shock waves through space, creating black holes and dispersing heavy elements like gold and uranium, seeding future planets and stars. Energy output. Hypernovae release about 10 times the energy of regular supernovae, equivalent to 10 to the power of 44 joules of energy. Exoplanet weather, hot Jupiters. Power. Some exoplanets, like hot Jupiters, experience extreme weather due to their proximity to their parent stars. Winds on these gas giants can exceed 5,400 miles per hour, 8,700 kilometers per hour, and temperatures can reach thousands of degrees Celsius. Effect. The intense heat can cause metals like iron to vaporize and rain down as liquid metal droplets in the atmosphere. Cosmic thunderstorms, magnetars. Power. Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's. They can produce starquakes and magnetic storms that emit bursts of energy across the electromagnetic spectrum. Effect. Magnetar flares can send out bursts of gamma rays and X-rays, capable of stripping atmospheres from planets and causing massive disruptions to nearby systems. Energy output. Magnetar storms release energy equivalent to 100 trillion tons of TNT in just fractions of a second. These celestial events represent some of the most intense forms of weather, stretching the limits of energy, magnetism, and gravitational forces. They shape galaxies, form stars, and create the building blocks of the universe itself.